Okay, so yeah, I know you're trying. I don't want to go too fast, so I know you're trying to copy that. But yeah, we're just going to kind of go through this story problem. So you have a ball that starts at 100 feet up, and you might notice in the equation, the 100 in the equation, that's like your starting position. Ball's at 100 feet up. It's being dropped. So if it's being dropped, it might make sense to you that this says negative because it's going to go down. When you drop it, it's going to go down. So then they are going to ask you to use that function and find the average velocity over a given interval. And I've underlined that word average up above too, average velocity, and they say average velocity. Because when you're doing an average, they're looking for how it's changed over a certain amount of time. And so right now, we're not doing the derivative yet. When they say average, it's just like plug in numbers and figure out the average changes in time and position and time. So yeah, that's why I underlined this word average, to kind of see it's just going to be like change in distance over change in time. We're not doing a derivative yet. So this is like going from 1 second to 2 seconds. In this, from 1 second to 2 seconds, how much does the ball drop? How much change in position over change in time? So you're going to use this function here and just plug in values like change in, you're going to use this change in s over change in time. So you're going to plug in like the second 2, like s of 2. Like if you put in 2 into that function for time, after 2 seconds, what happens? What if you plug in 1 into that function? So it sees like s of 2 minus s1, s of 1. And the bottom is change in time, 2 seconds minus 1 second. So you just grab a calculator and you plug in 2 into this function, like 2 seconds into that function. 2 squared, that's 4, 4 times negative 16, and then plus 100. So you have to figure out, do you know what you'd get? Plug in s of 2, plug in 2 into there. So again, since we're doing average, see, we're not finding the derivative of this function. It just is like plugging in values. So you know what you get? I got 36 minus what? Yep, 84. And then at the bottom is just the time change, 2 seconds minus 1 second, just 1 second. So 36 minus 84, it comes out to negative 48 feet per second. I added the label on at the end there when we went through this. So yeah, this was like the s was measured in feet, time was seconds, so feet per second. So that's the velocity, the average velocity. So I'm highlighting that word average. If they don't say average, if they say find the instantaneous velocity or just find velocity, if they say what's the velocity, if they leave out this word average, if they just say find the velocity, then they want you to find the derivative of this. Okay, so there's a difference. That's the main thing I noticed when I was going through this class when I was younger too. When they say average, it's like plugging in numbers, kind of like a slope, like difference, change in this over change in that. But if they just say the velocity, find the velocity, that would be the derivative of the position function. So what if I wanted you to find just the velocity of that function that we started with, not this average velocity? The velocity is the derivative of that s function, that position function from earlier. So do you know what the derivative of this function is? Like we did at the board? What if I asked you to find the derivative of this function? Do you know what you'd get? Yeah, you'd get negative 32t. So I wrote this at the bottom. Let me slide the camera down. There. Okay, so if you took that function, and if they don't say average, if they say find the velocity, then you do the derivative. Then you could plug in any number for t, like find the the velocity at time at t equals 2 seconds, or t 3 seconds, or t 4 seconds. Then you could find the velocity at any time value. Instantaneous velocity at any time value. You'd use this function. So yep, the derivative of the position function is velocity. And then another little side note is then sometimes they ask about speed of an object. The speed is the absolute value of velocity. Speed cannot be negative. But this velocity can be negative because velocity shows a direction, like a vector. So velocity shows it was dropping the ball, it's going down. So the velocity was negative 48 feet per second. But then if I just said, what's the speed would be 48 feet per second. So the speed is positive, same as the velocity answer, but positive. So yeah, you're going to get into those. So they're going to ask you to find averages, average velocity, where you plug in numbers and find the difference over time. Or if they just ask for velocity or instantaneous velocity, then you use the derivative and do the derivative function. So it's not too bad. It's just like using the things we've learned. And then we're going to get into, there's a couple where it's like free-falling objects that are affected by gravity. So we'll do one example of that too. Okay, so how did you get enough time to copy all that? I don't want to go too super fast. Okay, so one more example about a free-falling object. Let's see if we can fit that in there. So this one says you have, a position of a free-falling object under the influence of gravity can be represented by this equation. And you might have seen something like that in physics before. So the position function, s of t, equals -1/2. G stands for gravity. T is your time, so t squared, plus v sub 0, that's your initial velocity, times t plus s sub 0. So I wrote down what all those mean. Some of you already know some of those things. Like, a lot of you knew from physics, like v sub 0 is initial velocity. S sub 0 is your initial height, your initial starting point. Like that billiard ball was at 100, so the last equation had plus 100 at the end. The g is acceleration due to gravity. And sometimes we're like working on story problems that are talking about feet and seconds, so you'd use like 32 for the gravity, like 32 feet per second squared. Or if you're working with meters, then you use 9.8 meters per second squared. It just depends on the story problem. So yeah, you're going to see some story problems today, and if the problem starts talking about meters, then for the gravity number you use 9.8. If they start talking about feet, then you use 32. So let's try one of these. One question with this. You use this formula. And it was on like a PowerPoint in the... It's a PowerPoint. I can put it back up here quick. It's a question about a diver, like jumping off a diving board and like when they're going to hit the water. So I'll just pull that question up. It's from the PowerPoint. It's easier to just show you the PowerPoint picture of it, and then we'll work it out. Oops, let me move this over. Slideshow from current slide. Okay, so like this one, they're talking about a diver. I like the picture is good, to kind of see what we're talking about. The diver is jumping off the diving board, and they're going to ask you, when does the diver hit the water? And they also we're going to find the diver's velocity at impact. Now see, it doesn't say average velocity this time. It just says, what's the diver's velocity? So we're going to find the derivative this time. See that? So you got to pay attention to that. If they say average, it's not derivative. If they say average, you're like finding average from here to here. All right, so it says at time t equals 0 seconds, the diver jumps from the diving board. It's 32 feet up in the air. The diving board's up here. And they want to know, jumps off And the initial velocity of the diver is 16 feet per second. So we'll be able to plug that into our formula, the initial velocity. When does the diver hit the water? And what's the diver's velocity at impact? So when the diver hits the water, you could think like, what's their position then? Like they started at 32 feet. When the diver hits the water, what's their height? 0. So it's like, yeah, when's the equation like equals 0? So hopefully that helps to kind of visualize it. Okay, so let's go back and try to work it out. So we're using the formula. It's flipping back. And they told you there, looking at that story problem, they told you the initial velocity. They said that was 16 feet per second. So we're going to plug in 16 there. And they told you how high up the diving board was. It was 32 feet up. So the initial position, initial height is 32. And this was talking about feet per second. So for the gravity number, I'm going to use the 32 feet per second squared. So you're just going to plug those in. So I did that here. So the 32 goes for the gravity. See, the 32 number. And initial velocity, they said, was 16. And the initial position, the diving board was 32 feet up when he started. So you can clean this up a little bit. You can take -1/2 times 32 right at the beginning. So that will be -16 t squared plus 16t plus 32. Yeah, and they wanted to know when does the diver hit the water? Okay, so when does the diver hit the water? So we were just talking about that. When the diver jumps, off the diving board and goes down, when he hits the water, his position, his height, he's no longer 32 feet up. It's like, when does this function? It'll be like, when does this equal 0? Yeah, it's like, when does this function equal 0? So you just take this equation up here and equal it to 0. And I started factoring it here. Like I noticed I had lots of 16s and 32s. So how about we try to factor and solve it? That shouldn't be too bad. So you can divide out -16. Then you're left with this trinomial that you can factor some more. So 2 times 1 is 2. Yeah, -2 plus 1 is -1. You got to get your factoring figured out. So what does t equal? Good job. 2 or -1. But we're talking about time going forward. We're not going back in time. We want t to be a positive number. The time, we're not going back in time. So you're going to get rid of the negative answer. Yeah, t equals 2 and t equals -1. So we think the diver jumps off the diving board and they'll hit the water after 2 seconds. So it goes pretty quick. You jump, fall, hit the water, 2 seconds. So that's when the diver hits the water, 2 seconds. Then the second question was, what's the diver's velocity at impact at the 2 seconds? At 2 seconds, that's when they hit the water. So now they wanted, what's the velocity? Okay, so the diver hits the water at 2 seconds. So now velocity is a derivative of the position function. So now you can just go back to this function that we had and figure out the derivative of that. Okay, the velocity is like we said, derivative of the s of t function. So if you take the derivative of that, you get -32t plus 16. Then you can plug in the 2 seconds into that and get the answer of how fast, what's the velocity at impact. So hopefully you can follow all that. What do you think? Does that make sense? You take the derivative and then plug in this 2 number. And see, I got this from I just looked up here and did the derivative, 2 times -16 is -32t. Derivative of 16t is 16. So then you plug in 2 into there, and you should get your velocity. I got negative 48 feet per second. And again, what if I just asked you for speed? Like how fast was the diver?
It'd just be 48.
Yeah, so speed again would be the absolute value of velocity. That'll keep coming up this year. We'll keep talking about that. The velocity gives you like a direction that they were falling. Velocity is like a vector, it gives you direction. So velocity can be negative, but speed is 48 feet per second. So you're going to have questions like that you have to plug in numbers into this function. So hopefully it makes sense. Do you guys have any questions about it? It's okay. So yeah, these examples were on the PowerPoint. So if you want to look back at the PowerPoint and look through it too. All right.